So this is one of the exact equations, and we are attempting to solve it. Right, remember that we said for it to be exact, then partial derivative of the m part and the n part should be equal. So what we said was that either be the case, then the partial derivative of m with respect to y should be equal to the partial derivative of n with respect to x. So let's see. We will try to differentiate this one partially with respect to y and differentiate the n part with respect to x. Right, so the m part is s cubed plus 3xy squared. Differentiating it partially with respect to y, remember this part will be 0, so there's no need, but this part differentiate with respect to y, so 2 will come down, multiply it to 3, making 6, so 6xy. Then the n part, which is this part, will be 3x squared y plus y cubed. So differentiating it partially with respect to x, so it means we look at the x part, this part will be 0. We look at the x part, differentiating x, 2 will come down, multiply the 3 to 6xy. So both partial derivatives are the same, which means the equation is exact, so we can proceed and solve using either of this, that is the integral of the m part xy dx plus ry, or the integral of n part xy dy plus rx. Right, but this is the first one, what we introduced to in school, so probably if you are using that, the integral of the m part is the first part, so we are going to have integral of s cubed plus 3xy squared dx plus ry, or r of y, better still. So integrating this part, we have x to the 4th on 4 plus x, remember it's respect to x, so the y will be kept constant, so we have 3x to the squared all on 2y squared plus ry. Right, after integrating, remember this one is actually equal to f of x and then y. The next thing we do, because we integrated with respect to x, we will then differentiate with respect to y. Right, so differentiating with respect to partially, df on dy is equal to partial differentiation with respect to y. So without any y variable, any part will be 0. So this is 0, there's no y here, but there is y here. So differentiating, 2 will come down here and it will cancel this one, so we'll be left with 3x squared and then y plus y is here, so we can find the derivative. So after differentiating, what will be left should be equated to the n part. What will be left should be equated to the n part, so we equate the n part to this. So this is the n part, which is 3x squared y plus y cubed should be equal to the differentiated part, which is 3x squared y plus r prime of y, or ry prime, however you put it. So if you look at it carefully, it means this 3xy will deal with this 3xy, will be left with y cubed is equal to ry prime. What we do next is to integrate. So we integrate this part and this part, right? So the integral of this, we're going to end up with y to the 4th on 4 plus c, integrating constant, is equal to r of y. So you notice that right from the inserting the m part, what we did, this one from here, we have the first part of the answer, right? We have the first part of the answer, which is this one, the first part of the answer, this whole thing. So what we get here for the RY, we come and put it here so that the answer will be complete, right? So this is the value for RY. So the function f of xy is then equal to copying from what we have here, x to the fourth on 4 plus y to the fourth plus the integrating constant. Sorry, I left out this one, so let me add that one to it. So it means x to the fourth on 4 plus 3x squared y squared all on 2 plus y to the fourth plus c, right? And this should be the final answer.